Zeke's gonna do it too. All right, so today we'll finish up with our properties of logs. I believe next week we go on to the equations with logs in them, and then we got the quiz on, excuse me, on Friday. What are the two main things we can do with logs? When you are given a logarithmic expression, more than likely the directions will ask you to do one of two things. That's solve. It'll solve the question. When it comes to logs, you might be asked to expand or condense. Expand or condense. Now somebody said evaluate. Yes, you can be asked to evaluate a log, but that's kind of independent of the other two. Because sometimes you might have to expand and then evaluate. Sometimes you might have to condense and then evaluate. Evaluate just means that you're given a log that has like a constant and something. Hey, what are the two ways of evaluating logs? Change the base, which is the first one. Normally it's the second one that gets introduced because the fact is so calculator heavy. What's the other one? Change the base and common base. Change the base and common. So yeah, that is something you do with a log, but that doesn't have anything to do with expanding or condensing. The directions here for this one say to expand. When you expand or condense, you are using one of your three properties of logs. I know that we put 4 on that page before. This is what we introduced yesterday. But one of them was just change the base, which this is a type of evaluating. This is the way to evaluate. So really, when we expand or condense, we're using one of these three. In order to be able, what property are we going to use? Yeah, you look at whatever value you're taking the log of, what operations are going on. See a fraction, yes, obviously you're going to want to use quotient. When you use quotient, whatever is in the numerator gets a positive log. Now, wait, Mr. Romero, isn't the log supposed to have a base? Yeah, every log does have a base. And you might see this one, the one down here says log base 9. This could have been a log base 2, but if it says only log, what's the base? 10. So it will be log 4x. But then quotient property says that when you expand, okay, like we're basically just giving the log to each of these. But when you expand, whatever was in the denominator, that log is going to have a minus in front of it. Am I done? Has this been fully expanded? Why not? What? Okay, yeah, had the same, but I don't want to do that. Something that expanded. I'm being asked to expand. Has this been fully expanded? Is there any property of log that can be still used? When I say 4x, what does that mean? What does 4x mean? Come on, this is something I can ask like a 6th grader. They might even have a chance of knowing. What does 4x mean? 4 times x. 4x means 4 times x. What property of logs can I still use? Product. Product property still applies. If 4x means 4 times x, I can say that this is now log 4 plus log x, because when you're multiplying, both logs are positive, and then just drop down the minus log 1 as if it was constant. Now, 9 times out of 10, I'm going to be opposed to shortcuts, like where like, okay, if you have a really good understanding, it's more something like, okay, I understand if you would do a shortcut, but I really wouldn't advocate it, I wouldn't push for it. This is one of the exceptions. I think in this case you're probably better off with a shortcut. What do I mean by that? it is probably in your best interest to go from here to here. And the way that you would do it is, hey, anything that you're multiplying in the top, give that a positive log. So positive 4, positive x. Anything that's on the bottom, and even if you were, let's say down there that said log 2y on the bottom. Well, you'd have a log 2 and you'd have a log y, but both of them would be negative. Anything that comes from the bottom would be negative. Now am I done? Possibly. In this case, yes, but not always. The reason being, now that we have 3 separate logs, and yes, as far as expanding goes, we're done. We can no longer expand. But I told you that evaluating thing is independent of that. So we got to look at all these individual logs and see if any of them can be evaluated. The only way that a log can be evaluated is if you're taking a log of a constant. Like I don't know what log of x is or log of y. But maybe I can do log of 4. Now, the more that you get used to this, you can tell by looking at it that you cannot. But as we're getting used to this, why don't you go ahead and put log 4 in the calculator and see what you get. I don't care so much about the number itself. What I care more about is what is the type of number. Not just the decimal, be more specific. Yeah, I still don't understand what you said. Yeah. Huh? Yeah, it's an irrational number. So when you evaluate a log, when you're trying to either expand or condense, and the evaluating of a log gives you an irrational number, unless for some reason the problem tells you to round, which usually it won't, you just leave it alone. And that's considered to be our. Let's look at this next one here. What should we do? I want to expand. You said it? Was that you or was that Caroline? Oh, you can say that. Somebody said it. You say it. Quotient property. Sure, we got a fraction again. So that log of x to the 4th is positive. And so it should be a log base 9. We got to keep the same basis. Minus log base 9 of 7.9. Am I done expanding? No, I am not. If I go back and look at my properties, the other property that I haven't used yet, which is power property, says that when you're going to be expanded, any type of an exponent would have to be moved to a coefficient. So when you get the exponent and you move it out in front, even though you're not seeing more logs, even though you're not seeing log, that's considered to be expansion. So what can I still do here? What can I still do here? Move the 4 to the front. Like I said, this becomes 4 log base 9 of x minus log base 9 of 7.9. Now am I done? I'm done with expanding, but I still might be able to evaluate. The only one that could possibly be evaluated would be this one over here. The log of a constant. What are the 2 ways we learn to evaluate logs? Change of base and common base. Change of base is better because it's a calculator. You can get any type of number, rational or irrational, but that's also the drawback of it. You get a rational number that repeats, you're not going to know what it is as a fraction. But this one is going to work nicely either way. I like to defy convention when possible. So if you want to put that in, if those of you that are calculator hounds, if you look at the calculator, you can use change of base, and you're going to get your number. And I'm going to show you how I can get the same number using common base. What did you get on the calculator? You change the base, put in the calculator, tell you. Tell me for the past week. That's two calculators. So that's right fast. Did you guys already forget how to use change of base? Log 729 divided by log 9. What did you get? 3. You should have gotten a 3. The reason why you get 3 is because 729, if I were to rewrite it, is 9 to the third power. These logs cancel out, and really not now that we know the properties, this 3 gets to move to the front because of power property. So 4 log base 9 of x minus 3. Now that's simplest. I don't know, why is that confused face?
No, I was just I was at the time
All I did was I rewrote 729 as 9 to the third. The other way you could have done it on the calculator, as I said, is to type in log 729 divided by log 9, which is known as change of base. The original base is a 9. What are you changing the base to? Writing it that way, what are you changing the base to? What am I changing the base to? Just say log, what am I changing the base to? Seriously, not even one person knows what the log is. What do you say log? 10, yes, we're changing the base. Most calculators are capable of doing 2 types of bases. One is a base 10, which is just a log. What's another name for that? What's the name for a base 10 log? What's the name for a base 10 log? It has a name. No, the other one. Said it? Thank you. It's a common log. The other type of base that a calculator can do is what Thomas just said. It's the natural log. What's the base on a natural log? What's that one? Gosh, you had a question? You have 2 options. Behind door 1, you can do this and change 729. This is option A. But that's going to help you evaluate that. Or option B is to do this. Regardless of which one of these options you choose, they will both end up giving you 3. Those are 2 ways to evaluate a log. One is change of base, one is common base. Common base doesn't always work. Common base only works if you're getting a rational number. Yes?
We solve for x.
How are you going to solve for x?
That's what I'm asking.
Yeah, and so you ask, are we going to solve for x? And then I asked, how are we going to solve for
No,
x?
that's can we.
Can we? Okay, so then it's gonna be written. How would you? You said can we, so how would you? When you solve for something, what are you trying to do? Like, what should be there when you're solving for a variable? An equal sign. You see an equal sign? I do not. There are expressions. Now, we typically with expressions, what we do is simplify. When it pertains to logs, kind of branch simplifying off into 2 rungs. One would be expanding and one would be condensing. You can consider them both under simplifying. It's just 2 different logs. Can't solve for this. Now, I want to say it's next week. Next week, we will start solving for a variable that's going to be inside of a log, but you're going to have an equals and something like this inside of the variable. Okay, so back to yesterday. Alexis, you with us? Okay, as Thomas said, this is a natural log. You're supposed to write a lowercase l, but lowercase l's look like either 1s or the letter I. So if you write a capital L, it'll be right of secret. It says 2ln15 minus ln75. In order to write as a single log, which we did towards the end of yesterday, I know in the last 5 minutes of class I used what little attention we had left, but if you weren't paying attention, what has to be true in order to write as a single log? In order to combine logs into one, what has to be true? Same base, and guess what? If that one ain't true, you ain't doing anything about it. It's your stuff. It's gonna stay that way. You can't fix that. But what else? There's a big one. This one you can't fix. Not only same base, but same close. Another C word. Coefficient. Same coefficient. Same number in the front. These do not have the same number in front. But how do you know now that we can fix the number in front? Property. Power property. I can use power property to say, okay, Mr. 2, we don't like you. I'm going to move you up here. Let's say ln of 15 squared minus ln of 75. 15 squared is 225. Now I have same coefficient. I have a base. How can I bring those together? Because of the fact that the second log is negative, yes, it would be quotient property. So I would have ln of 225 divided by 75. And that just gives you 3. I have now accomplished what I wanted to. I wanted to write as a single log. But independent of that, you got to see whether or not that log can be evaluated. And 3 is a constant. I know that it cannot be. Anything involving ln, if you don't see an e there, you ain't going to evaluate it. And but just for now, just to get your feet wet, put ln of 3 in the calculator. And then you see what it's an asking number. You like logs?
Yeah.
That just looks hard. Same direction, right? Right, and then if you go to the single log, it's right at the single log. In order to write as a single log, it has to be true. Same base and same coefficient. All the bases are the same. These are all ln's, which have a base of e. But all the coefficients are different, but luckily we can fix that. How can you fix it in order to make bases? To make coefficients the same? Power property. So I could change this first one to ln of, here, let's call this x to the third plus ln of y squared plus ln of 5. Now that all the bases and coefficients match, I just have to know what property is going to bring them together. Because all of those logs are positive, what property is going to bring them up together? Product. So what is x to the third? What is x to the third times y squared times 5? You're the second person that says it today. Think. Yeah, that's like when we're like, oh yeah, if yes spells yes, what is EYES? And then people say like, oh, it's a yes. No, eyes. So yeah, please don't say that this is x to the third y squared 5. People have told me that today. This is just 5x. And in this case, you've already condensed. Nothing there can be evaluated yourself. Questions? All right, last 2 slides. Don't worry too much about this. These are just kind of prerequisites saying that in order to do what we're about to do for these first 5, like this has to be true, but you probably would have already assumed that anyways. Anywhere you see an A, it's telling you that A has to be greater than 0 but not 1. Anywhere that you see an M or an N, those have to be greater than 0, which means positive numbers. And anywhere you see a P, it just has to be a real number. That just takes away counterexamples. You don't have to worry about this example part. What I want to do is give you like 2 minutes for this. You know what you're doing is you should not take more than no calculations to be made. These are all letters. I see one number in the entire thing. But it's just a matter of, do you know how to use your your properties of logs? I will tell you, the first two look like they would be expansions. The third one is that it's hard to tell, but it's really this is considered part of making it a single log, even though you only see a single log. And the last two are evaluations. I'll give you like literally 120 seconds.
Don't even worry about that. That's just saying that the set of all p's has to be a real number, but that has no effect really on what you're gonna write.
All right, so let's see if we did. First two should have been about as easy as possible. Just thinking about a combined 15 seconds. If I expand the first one, what should I get? Log base A of M plus log base A of M, because you're using product property. With product, both logs have to be positive. What should the second one of you do? Log base A of M minus log base A of N. That's quotient property. The log that goes to the denominator needs to be negative. 3 might have been a little bit tricky, but the only thing that you can do here would have been to move so like even though we're not starting with something like when you move a coefficient to an exponent, that's considered condensing. When you move an exponent to a coefficient, that's considered expanding. So I wish the directions would be a little more clear, but fine. This would be log base A of M to the P power. Nothing else you can do there. 4 should have been also pretty simple. 5, I'm curious. I don't think anybody got this last period. 5, but let's see 4. When you take a log of the same base as the base of the exponent, what do you get? Not 0. You get 1. Reason being, if these were to cancel out, all you would be left with is whatever exponent was up here. You don't see an exponent, what exponent is in? 1. How about the next one? Wait, but I don't get it. What do you mean log base A of 1? I don't even know what A is. But we do know from up here that A has to be positive. if you learned a few days ago, right, we just, let's say Julian, don't get confused on this, all right? I'm throwing in an equal sign, we're not solving anything. Let's just say we say equals y, just for the sake of argument. We learned 2 days ago how to convert. We're not solving anything, but we how to convert between logarithm and exponential. That means that I can say that a to the y power is equal to 1. Remember, we're looking for y. We want to know what this is equivalent to. We want to be able to evaluate that. So the question is, what power can I take any positive number to and get 1? Are you meditating? No. Calculator, you like better? We're on a boat and both calculators are drowning. You can only save one. Which one would it be? So you get a better calculator then? I'll take that one, keep it around. Any questions so far? Alright, so I made the mistake of letting my math period try to do these on their own, and not that they're hard, but all they did was that they stared at them for 5 minutes. So we have more that are just like this coming up afterwards. So let's do these 5 together, and then I'll let you do the next 5 on their own. The nice thing here about this is that these are all constants, but just so that you know that I know that you know that I know that you know that we know, depending on the calculator that you have, what do all of these have in common? On all of these, you're taking the log of a constant, not variables. But when a teacher wants to try to limit students' use of a calculator and make sure that they know properties of logs, they tend to give them problems that have variables because there's not much you can do with a calculator when there's variables. But again, depending on the type of calculator, you might be able to just type these in as you see them and hit equals if you are good with a calculator, and it's going to give you the answer. If it were a multiple choice, whatever, it's just the nature of the beast, fine, you get away with it. By pulling that stuff on a free response, cock out your face, even if you get the right answer. Sorry. No soup for you. So I would make sure you still know the properties of logs. All right, first number 1. What property of logs are and actually, you know what? Let's read the directions first. What do these want us to do first?
Condense.
They want us to condense. So some of you said that they're all expanded. Yeah, kind of. Even though 3 is not expected. But they want us to condense. And then evaluate when appropriate. Meaning if you can evaluate, then go ahead and evaluate. So how would I condense the first one? Quotient, we have the same base, they both have a 1 in front, we would use quotient property. This becomes log base 3 of, you divide, and when you divide, it has to be the positive log divided by the negative log. Because of course now what they're going to do to throw you off is put the 2 here and the 162 here. Because if that were the case, it would have to be 2 over 162. But with 162 divided by 2, that gives you 81. I have now condensed. There's nothing else I can do to condense. But what can I still do? It starts with an E and I can evaluate. I can still evaluate it. There are 2 ways for like the 5th time today. What are the 2 ways to evaluate log? I even had a nice like embedded calculator on the screen earlier this week. I can do change of base, yeah, that might be the easiest for most of you, where you would just do log 81 divided by log 3. Or you can do common base, which is a little more, relies more on mental math. I'll let you guys do the easy one and I'll do the harder one. And when you did change of base, what did you get? Yeah, so the reason why you got 4 is because here I write the log base to be the same, but Josh, that 81 there is the exact same thing as saying 3 to the 4th power. You don't have to do it that way, but I do it this way so that you can see it like it's, I think it's a bit more explicative, if you will, than the calculator is. The log base 3 cancels the base 3, and what do you end up with? What do you end up with? Due to which property? That's how you need to know this, but this requirement. What property comes with this 4? Because the 4 is not hanging out in the exponent, it's power property. Yeah. Caleb, how about the next one? What property am I going to use? I want to look at you and that's frozen. Not here right now. Leave a message. I'll get back to you as soon as possible. Hey, Caleb, what's up, man? Mr. Romero. That's the message today. The chance to come back. Okay. What do you see on number 2? Yeah, what else do you see? What else do you see? What else do you see? Yeah, there you go. You see addition. So we have different logs. Okay, we have 2 logs and addition in the middle. And I want to get those 2 logs to bring them together. When I bring them together, when there's addition in the middle, what property am I using? Product. So I'm going to get those numbers and I'm taking the log of and I'm going to multiply them. Product means multiply. What is 4 times 25? If I have 4 quarters, how much money do I have? 100. Now this log was a common log. It's just log, which is a log base 10. So I don't have to write the 10. I can just write log. And 4 times 25 is 100. Do we need to change the base here? No, because your calculator does common logs. Every scientific calculator does common logs. Let's type in log 100. I can do this as common base. It's silly. This is easy. For the next one, somebody last year said, whoa, but Mr. Romero, can I just take 32 to the 3rd power? Sure you can. Go for it. It's going to be a big number. I try to avoid calculator if I don't need to. So if I'm going to be like properties of logarithm ninja, what I would do is I would get the 3 and move it to the front if I'm allowed to. That is power property. So I would say this is 3 times log base 2 of 32. If you get that far and you still want to use the calculator, you can. You can use change of base, log 32 divided by log 2. Have a calculator handy, tell me what you get. Well, log base 2 of 32 is 5, but yes, once you multiply by 3, that gives you the 15. Josh? So here's 3 log base 2. I just got that 32 is the same thing as saying 2 to the 5th. So if I cancel out those 2's, and that 5 goes into 3 in the front, what is 3 times 5? Just to show you that there's more than one way of doing this. If you do have that calculator handy, go ahead and take 32 to the 3rd power. Get that big number. Okay? And in that case, now you've taken care of all of this. So just do log of that big number divided by log 2. And see what you get. It's still going to be 15. Yes, Julian.
What's a bigger number? How would you know, or how do you put it in the calculator?
What was a bigger number?
Like 32.
If 32 was a bigger number?
Yes.
How do you get a bigger number?
Like 3 to the 5th, right? Like, that's an easy number, but I need like, what's a bigger number? So, what would you put in our calculator to know that? It's, like 32 is a 2 to the 5th, right?
Yes.
Okay, so how, like earlier it was 729 is 9 to the 30. So how would we put in our calculator?
one has nothing to do with the other. Same 9 to the third is common base. That there you're avoiding a calculator. And with the 729 one, like I could go back to that one. Like you could have just done log 729 divided by log 9. Like you could put big numbers into the calculator. If your question is how would you do big numbers in your head, yeah, maybe you would. You have to use that. I don't. Like I just don't understand. Like how can you say how do you put big numbers in a calculator?
I think to see what's the power, like, it's hard to explain, but what I mean is like, if it was a big number, I had to see what's the base and what's the
But the base of the exponent is back to what I said. That's when you're doing common base. But if the number's too big, you probably don't want to do common base. Just use the calculator and you change the base. Yeah. Like, hold on, hold on. Like Julia, I don't have to know that this is 2 to the 5th to use the calculator. I didn't use a calculator here. I asked you guys to use the calculator so that you can have your aha moment and see that we're getting the same answer. But I didn't use a calculator here. You don't need a calculator to know it's 2 to the 5th. So look, if I wanted to use a calculator, then this is what I would have done. I probably still would have moved the 3 to the front, but I would have said, hey, this is just 3 times log 32 over log 2. And that would have given me my 15.
So you're just taking a short.
Doing it mentally. Showing you to move one way. Yes, Juan.
That was my question.
Okay. For the next one, number 4, how can we do that one? Caleb, you want to try that? No, Alexis, you want to help him? It's only like the exact same problem twice in a row. Same plus is there that was before. Okay, today. Jonathan? Yeah, product. Yeah, both blocks are positive, so product. Log base 4, 64. So yeah, I don't know if you consider 64 to be a big number or not. If you want to try to find the common base, that shouldn't need a calculator. One has nothing to do with the other. If you just want to use the calculator, use change of base. Log 64 divided by log 4. I don't consider 64 to be a big, and it's not even about big or not. There might not be a common base. 64 and 4 might not have a common base, but it does. And it's that 64 is 4 to the 5th. So the log base 4 cancels out the 4. Power property allows you to bring it to the front. End up with 3. Okay, we go to number 5. Now, see, when it be multiplied on, now the sign in the middle has changed. Yeah, you divide. What's 600 divided by 6?
It is
100. So for the second time on this page, we're taking the log of 100. You don't have to change the base. You don't have to divide anything. Your calculator does common logs. What's log 100? Those. Stay here off the quiet today. Lost or you're good. All right, so then like these next 6 are almost identical. I can give you maybe 3 minutes because we're a little bit behind. See if you can get a head start on these. Yes, sir. Man, it would work. Good luck, you're gonna have to work very often. It just happens to be, you just happen to be lucky that both separate logs have common bases, with the base of the log, and then you could, I would follow, the thing here, first parenthesis log, and then simplify. But yes, I mean, that would actually work. That would work very often. Yes. Well, I'm gonna do all of them. Skip it. All right, do you finish them already? They're not supposed to use the classroom. Okay, so if you finish number one, what'd you get? What'd you get for number one? Yeah, it should have been one. The use quotient property. It's, they're both log base twos, you bring them together, 32 divided by 16 is 2. Again, be careful with quotient property, because if they put this backwards and do like a 16 and then a 32, well, you wouldn't be getting 2, you'd be getting 1/2. When you're taking the log of a fraction, you're gonna end up with a negative. I get these notes from the same place that everybody gets the notes. I don't know if you see any of those. There won't be many of those on the assessment, but just be careful. And then, yeah, once the log matches the base, that just gives you. Okay, we can do the second one. Okay. Yeah, finished. Log didn't mention the base. Lord, they haven't talked to you today. Okay. Here's number 2. That's number 2. Well, let's go to order. Number 2 is product property, and as Caleb said, 12.5 times 10.
What is equal P?
125. What?
P?
Yes, Julius. I'm showing off for the ladies. You should get log base 5 of 125. Caleb, that should have on your paper. I don't know if you put the 5 there. Now, but once you get there, that log can be evaluated. You can either do log 125 divided by log 5, or or yes, you could do a common base, which is what I'm going to do today. Log base 5 to the third. The point is, you can do 3. So the next one, land and demanded. What property? This is quotient property. 343 divided by 49 is it 7? So, when you're taking a log of a number that's a fraction, you're gonna get a negative. But when you're taking the log with the big number, like the physically big number, is less than the base of the log, you're gonna get a fraction. So you can do this with common base. I probably confuse you doing that by common base. So I would just tell you to do it on the calculator. Put log 7 divided by log 49. What do you get? Depending on how your calculator displays it, it'll either say 1/2 or it'll tell you 0.5. As long as you're not rounding, we're okay. Okay, now the super duper hard one. Just like on the first one that we did with the one that Julian was asking about the big number today. If you want to just take 16 to the third power and then do change the base, you can. Or you can, the ladies like it better when you use power property first. And then so you'll say 3 log base 2 of 16. Yes, sir. Oh, I just want to finish. Log base 2 of 16. 16 is the same thing as saying 2 to the 4th. But you could have also just put log 16 divided by log 2. When that 4 comes to the front to meet the 3, what's 4 times 3? 12. That's that. The next one, log 20 plus log 50. Very good. That is product property. 20 times 50 is 1,000. And even if I don't have a calculator, if I understand that the base of a common log is 10, what power do I have to take 10 to get 1,000? And how do you know that without a calculator? 1,000 has 3 zeros. And then the last one was the first period is longer than second period. They have a little bit more time. I gave them more time to work on this. And what I found hilarious is that they knew how to get to this part, but they didn't know what to do after that. They knew how to use product property. They didn't know what to do after that.
Log 13 divided by log 8.
I gave you the exact problem like 2 days ago. 2 days ago or yesterday? Same one. Log base 8 of 32. Hold on. So now if you put that in the calculator, you put log 32 divided by log 8, you will get a rational number. And you can tell because it repeats. But you probably have to make that fraction decimal button thing. Or, if you remember from a few days ago, we said, okay, this is the same thing as saying 8 to the y. 8 to some power is equal to 32. So when you do common base on both sides, 8 is 2 to the third. The y is already there. I can multiply them power over power. It's on your notes. I know you don't see it on my screen, but it should be written in your packet. We did it. And it should be 2 to the fifth. So since both sides have the 2, I can say that 3y is equal to 5. Divide by 3. Y is 5. It's the same thing that was on your notes. Not done yet. Last one. These are inverses. What does inverse mean? You know what inverse means? Opposite, they cancel out. So look, real quick. This first one here is obvious because like we're used to it. The base of the log cancels out the base of the exponent and it's x. But like for this next one, what? I haven't seen a log and an exponent before. Okay, so do what we just did over there. If I throw a y in here, and then I were to change this to log form, this base becomes the base of the log. So I would say log base a of this y from the other side is equal to log base a of x. So the whole point is that y is equal to x. Whatever I was looking for, which I just called y, ended up being the same as x. The a and the log base a cancel. So can you use that logic to, in 30 seconds, let's finish the rest. What are we going to get on this the next one here? That cancels out to 7. What do we get on this next one? F plus 3. What do we get on this next one? 2r minus 7. How about this one here? Plus 28. What do we get on this next one? Because the 10 and the log cancel out 5x. How about this next one? When the base of the log matches the base of the exponent, they cancel.
Where do you get the variable from? Number 6.
The what?
You just put in your random variable number 6.
Yeah, we did that a couple days ago where we